Quite a few days ago, I have posted an article on Terraform functionality and amazingness. Now it's high time that we roast it. I'm joking. Today we will just discuss some problem with Terraform, and then at last we will just give you the solution, or the solution which I have written on my Obsidian file, some best practices that you should use while using Terraform for your organization. So problem number one. Oh, where is my marker? So problem number one, I hope the screen is visible. Problem one is provisioning versus configuration problem. So I have seen this with people that they confuse Terraform as provisioning infrastructure tool or configuration tool, because the Terraform originally has been positioned as, when it came into the market, it positioned itself as a provisioning tool. So it is used to create the end desired state of an infrastructure, but not configuring it. So it is not used to configure it. So let me relate this model to a house model so that you could understand it better. Okay, let's suppose there is an infrastructure company. So it helps you with building the house, putting bricks into the place, and it created you the raw house. But in order to live in that house, you need electricity, you need water, you need gas, you need furniture. Okay, you need lots of things in order to survive and in order to live in that home. Okay, you need entertainment purposes things. So relate those house and infrastructure company as a Terraform, and those things which you need to survive there, you need light, electricity, water, food. These are all configuring it. Okay, you are configuring the house in order to sustain it, in order to sustain the life in it. Okay, so the same way, the way we provision infrastructure, okay, and we need to configure it in order to make the application run on that infrastructure. So when you are provisioning the infrastructure, it just means that you have created the EC2 instances, you have RDS and VPC enabled and created. But in order to do things in it, you have to use configuration tools like Chef, Puppet, and Ansible to actually download web servers like Nginx and make it secure by downloading firewalls in it and providing creating Linux users for access control and all of those things. That comes under configuration roof. So you have to use Ansible and Chef, Puppet, all of those things for a configuration part, and Terraform only for provisioning the infrastructure, because it is what is great in. Now, second problem is state management. So Terraform, unlike developers who put their codes onto a GitHub, which they seems like to use Git as a single source of truth for keep tracking of their changes and collaborating with other developers, Terraform uses terraform.tf state file. Terraform instead uses something called Terraform state file. So it is nothing but information about the infrastructure that Terraform has created and sensitive information related to the infrastructure. So this state file is named as terraform.tf.state, and it is the single source of truth for Terraform. When you do Terraform init, when you initialize the Terraform, it just go and matches the Terraform state file with the actual infrastructure and see what has been, if there has been any mismatch in the infrastructure and my state information. So just Terraform keeps information of state. The Terraform keeps information of the state of the resources through state management file, to state file, Terraform state file, which is known as terraform.tf.state. Now, what's the problem with that? You have to push it somewhere. Okay, you have to store it somewhere. So you can't put it locally, because if you have put it locally, then in other developer system, Terraform does not have any context of your Terraform infrastructure. Okay, so you have to store it somewhere. So you think of storing it on GitHub, but GitHub is a distributed versioning system, and for the distributed versioning system, state file is not a good option. Okay, let's suppose if you have pushed that into a GitHub, what would happen is, when you have pushed that thing into a GitHub, someone has forked that repository. Okay, fine. But later on, you have changed the infrastructure. Later on, you have changed the infrastructure with somehow, let's suppose you have created something else. Let's suppose you have configured a different VPC or something like that. Now, the developer who have the forked repo 1, and which has the fork repo 1, and there is it's a complete different file. It's a complete different state file. So it has the old information and it does not have the new information about the infrastructure. So what would happen is that now the two DevOps developers have different state files of the same infrastructure, and which created conflict. So that's why it is not a good practice to push this state file into a GitHub. Now, if we can't push into a GitHub and we can't keep it locally, then what should we do? See, we could set up something called remote backend. It has been clearly stated in the Terraform documentation. You could go look out it officially what remote backend means, but if I want to explain it very simply, the ideal Terraform setup is just like this, that you store this Terraform state file into a S3 bucket, and S3 bucket can be in AWS, and in Azure it could be resource manager, and in GCP it could be storage. I don't know what we tell there. I think it is volume, and you have to connect this S3 bucket with a DynamoDB database. Now, what this whole architecture does with state file is that first, this thing enables versioning. Okay, so now Terraform can actually update the Terraform state file with time when resource and modification happens. Okay, versioning is enabled. And second thing, with the DynamoDB based locking system, two users simultaneously cannot change the infrastructure. So only one user at a time can access and change or manipulate the infrastructure, which keeps things in place and reduces the number of conflicts. Infrastructure drift. Now let me introduce you with infrastructure drift. Let's suppose you have created an EC2 instance with t3.micro. Okay, you have created a t3.micro instance with a Terraform script. Now someone has AWS console, and according to their need, they have changed that t3.micro into t3.medium. Now Terraform does not have any fucking idea about this change, and so what it will do, it will get corrupt. Not Terraform itself, but the Terraform state file. The Terraform state file would get corrupt. I would have no longer information about what the infrastructure is about. It would tell you that, okay, Baba, I've give up on this infrastructure. I don't have any information about the infrastructure. You should go and resolve this manual change, or you have to resolve the setup. You have either two options. So this is all about infra drift. And this is now the problem 4, large state. Okay, large shared state. What do I mean by large shared state? Is that organization grows, and so does their infrastructure. And with the growing infrastructure, the state file becomes more and more complex, and we need some way to fight it, and we need some way to simplify it, because with state file going more and more complex, it becomes very difficult to do day-to-day operations in it, to plan it, and to see bugs in it, and to find things which are going wrong in our state file and in our infrastructure. It becomes really tedious process and very difficult process. So what we could do is here that we could split it. We could split the entire infrastructure. We could split that file into clear different segments with clear ownership model. Now, what do I mean by ownership model is that each and every segment has a clear owner and has a clear supervisor to look at. So it could go segment into environment, application, access, thing, and infra layer. So all those segments would have their own owners looking at them and supervising them. So that is the concept of dividing or segmenting the infra file, state file into a bunch of things. Now, problem 5 is read plan carefully. Okay, what do I mean by read plan carefully? See, with regular changes and modifications and deletions in our Terraform state file, things become messier, and some creation of particular resource, and sometimes creation of one particular resource could lead to the deletion of other. So it has become a necessity that we regularly, on a regular basis, we check plan and we do read plan carefully of our infrastructure by doing Terraform plan. It's simple, but it's a simple process, but it saves you a lot of times. It's a simple process, but it saves you at your worst times. Now that have been looked to all problems of our Terraform IAC tool, now it's high time that we look into the solution. Now, the solution part, I have written some best practices from the different documentation that I could find on this, and here are the simple steps that I would just spit it out. You could just screenshot it, or you could write it out in your diary or somewhere. So yeah, what should a production ready Terraform workflow look like? Use Terraform for declarative infrastructure provisioning. Now, what do I mean by declarative here is that Terraform is used for creating the end desired set of infrastructure. So it is declarative, and it does not give you step-by-step processes. So it is not procedural, but it is a declarative infrastructure provisioning. Okay, got it. Store state remotely and protected. We have already covered it by, you just have to put your state file into S3 bucket or any storing services, and then connect that storage services with the DynamoDB database that provides locking capability functionality. Okay, now run Terraform plan through CI/CD, separate states using meaningful ownership boundaries. Review every production plan before applying it. Use a secret manager for secrets. In AWS, it is, I guess, SSM, and I don't have enough knowledge about Azure or GCP. So you could just Google it, what secret manager they use, and you could use them for secrets, for secret rotating, retrieval, and deleting. Use configuration management and operational tools for configuration management and operational tools for tasks Terraform was not designed to own. And treat manual cloud console changes as control exceptions, not the normal workflow. See, Terraform limitations does not make it a back tool. It doesn't work that way. It just has been this, where Terraform strength shines, let it shine. And when Terraform is not able to do some things, there are other bunch of tools which could make their way in and help you with the infrastructure making a success. So they show us where Terraform's responsibility should end and where another process or tool should begin. The goal is not to make Terraform manage everything, but the goal here is to build an infra system which is secure, reliable, and maintainable. So I hope you love this technical explanation, and if you loved it, I really hope that you check my article on Terraform that I posted 1 week ago, and I think you enjoyed it. And if you enjoyed this technical explanation, make sure to engage in comment section and tell me what part of this technical explanation you loved, and what did you learn about it, and tell me something which I could improve on. Okay, see you in the next explanation. Bye bye.